Imagine you are watching a radar screen. Suddenly, 100 targets appear at the same time. Not missiles, not aircraft, drones, all heading toward the same city. You have 30 interceptors left. What do? You have seconds to decide. And while you are thinking, they are getting closer. This is the problem of the drone swarm, and it is not what most people think it is. To understand why drone swarms are so dangerous, you first need to understand what they actually are. A drone swarm is not a group of drones that happen to fly in the same direction. It is a coordinated attack where dozens, sometimes hundreds of drones work together as one system. They communicate with each other. They divide tasks. If one drone is shot down, others take over its role. Think of a murmuration of starlings. Thousands of birds moving as one fluid shape through the sky, without central control, purely based on simple rules each bird follows. A drone swarm works on the same principle. Each drone follows a set of instructions. Together, they create behavior far more complex than the sum of its parts. And that is exactly why they are so hard to stop. The first problem is math. An air defense system can track a target, calculate its path, and launch an interceptor. But that process takes seconds. Now imagine doing that 50 times at the same moment. If 50 drones appear on radar at the same time, the system quickly runs into a hard limit. Not enough time, not enough interceptors, not enough launch systems. There is no air defense system in the world that can guarantee complete protection against all threats simultaneously. That is not an opinion. It is a physical reality. But the math is only the beginning of the problem. The second problem is the cost. Imagine an attacker launches 100 drones. Each one costs around $5,000. Total cost was $500,000. The defender fires 100 interceptors. Each interceptor costs hundreds of thousands of dollars. The defender successfully shoots down every single drone and still loses the economic battle. The attacker spent a fraction of the cost. The defender spent tens of millions of dollars. Now do that 3 times. The attacker has spent $1.5 million. The defender has burned through more than $100 million worth of interceptors. The defender wins every individual interception and still loses the war of attrition. The third problem is intelligence. Early drone swarms were relatively simple. They followed pre-programmed routes. If you jammed the signal controlling them, they stopped working. Modern swarms are different. They can coordinate with each other, share information, and adapt if drones are destroyed. Instead of one operator controlling the swarm from the outside, the swarm behaves like a system, making decisions from within, and that makes them far harder to defeat. Electronic warfare, which was once a reliable countermeasure, is losing its effectiveness against swarms that can navigate autonomously, without GPS, and without a signal to jam. The fourth problem is scale. A traditional weapons system, whether a fighter jet, a missile, or a tank, costs millions to build. You cannot produce thousands of them quickly. A drone costs hundreds to thousands of dollars. You can produce hundreds of thousands of them. Ukraine sent more than 1 million drones to its frontline units in a single year. 1 million. No air defense system in the world was built to handle 1 million threats per year. The production capacity for interceptors simply does not exist at that scale. And even if it did, the economics would still not work. So what are defenders actually doing about this? There are 4 main approaches, and none of them solve the problem alone. The first is the traditional interceptor missile. It works, but as we have established, it is far too expensive to use at scale against cheap drones. The second is electronic warfare. Jamming signals or GPS can disable some drones. But modern swarms that operate autonomously are increasingly resistant to this. The third is directed energy, lasers, and high-power microwave weapons. In theory, a laser can fire thousands of times at the cost of electricity instead of $1 million missile. Some systems are already operational for short-range threats. But current technology still has limitations in range, performance in bad weather, and the time needed to neutralize each target. And finally, defenders are experimenting with drones fighting other drones. A single interceptor drone or a high-power microwave pulse could potentially disable dozens of swarm drones in one pass, without spending a conventional interceptor on each one. None of these solutions work alone. The emerging answer is a layered system. Multiple different sensors and weapons working together to compensate for the weaknesses of each individual approach. But even a layered system has limits, and the people designing these swarms know exactly where those limits are. Which brings us to the biggest challenge of all, the one that goes beyond the technology: speed. So why are drone swarms so hard to stop? Not because the technology to defeat them does not exist. It does. But because they create 4 problems simultaneously that no single system can solve on its own. The math does not work. There are always more drones than interceptors. The economics do not work. Attacks are cheaper than defending against them. Modern swarms are intelligent enough to resist traditional countermeasures, and they can be produced at a scale that exceeds anything air defense has historically had to deal with. The answer is not one technology. The answer is an active, layered system of defense, multiple sensors and weapons working together, covering each other's weaknesses. But even that has limits, and the race between attack and defense is moving faster right now than at any point in modern history. That is why drone swarms are so hard to stop. A human operator making decisions about 100 simultaneous threats is fundamentally slower than an automated system. But an automated system making hundreds of decisions per second raises questions that technology alone cannot answer. Who decides what gets shot down? What if the system makes a mistake? What if a commercial drone is misidentified as a military threat? The technology can accelerate the decisions, but the responsibility for those decisions remains with human beings who may have only seconds to act.